So in this video what we're going to do is use the Sweatt glass with the KPX094 Newport lens to make a chromatic corrector. With this as our starting point, the basic lens with the three wavelengths that we're designing over, and we'll show various improvements as we go along. So all we have to do, we're going to be adding this Sweatt surface here on the flat side, which is the easiest to fabricate the diffractive on, and several ways to fabricate that. We're not going to go into that in this class, but it's safe to say that flat surfaces are much easier to fabricate the diffractive surface on than a curved surface, although curved surfaces aren't uncommon to fabricate these guys on. Alright, so all we do is we go up here to our lens data editor and insert a glass between the image plane over here and this flat surface. And so if we put our cursor here and click on our left mouse button, we're on surface 3 there, and then you use the insert button on your keyboard and you've just inserted a lens. And the radius of curvature of that surface is infinity, which is actually the back side of the BK7 here. And so what we're going to do is we're just going to add the Sweatt glass there, S-W-E-A-T-T, with I just hit return, and it says glass Sweatt. Oh, I didn't want to use that. I'm sorry, cancel. Okay, we're going to do my Sweatt. Okay, which was in the miscellaneous catalog. Okay, let me try that again. Oops, I hit delete. Oh boy. Okay, insert my S-W-E-A-T-T. Alright, so it got it. It'll come up with a message to, change the catalog or add the catalog. You want to go ahead and do that. And so the thickness of the Sweatt surface would be something like 1/10 of a micron or so. So this lens units are in millimeters. So what I usually do is just enter about 0.0001. It doesn't really make too much difference there. You just want it very, very thin. And then the first thing that we're going to do is change the radius in adding power only to the Sweatt surface. So that we enter here, and in order to change that to a variable surface, we'll go solve type, and then we'll say variable. Okay, and now I've got two V's here. It's going to change the radius of this surface and the distance from the Sweatt surface to the image surface here to the focus as optimization parameters, and this uses, I think, a damp least squares type optimization to minimize the merit function. So we're ready to go here, so we just hit optimize, and our merit function right now is 2.3. Let's try 10 cycles of the merit function. See how it goes. Ooh, that's pretty good. So it went from 2.3 to 0.7, and we exit out of that. Now there's a global update I use the hotkeys. I think it's Control-Shift-U, and it updates everything. So now you can see with the spot diagram how much better that is. There's the diffraction limited performance down there with that little black circle. So we're quite a ways away from that. But we're not too bad. We've gone from 10 waves here on our scale to 5 waves, and now the peak variation is much smaller. And you can see that the variation of the wavelengths in their performance isn't nearly as much as it was before, and you have the characteristic curve here due to spherical aberration. Okay, so the next thing we want to do is add in the spherical. So the way we do that is we change the Sweatt surface from a standard surface. You put your cursor over there, click the left mouse button, and click the right mouse button, and you want to add a surface type of even asphere. Okay, see that? And that's really all you have to do. You hit OK, and now you've got an even asphere there, and it's going to keep that same radius. This is in millimeters, so it's a very, very long radius. But let's go over to the aspheric coefficients there, and I'm just tabbing over with my arrow key. And what we'll do is we'll just add in a single fourth order term and optimize that as one more variable by selecting my right mouse key over that term and selecting variable solve type, and then go back to my optimization and again try 10 cycles, and then now I'm down to 0.2. Okay, so let's go out of there and do our global update, Control Shift U, and now that's pretty decent actually. We've got 0 to 2 waves of wavefront here with pretty decent wavefront. It's not great and perfect, but it's a whole lot better than it used to be. And it's not quite diffraction limited, but it's much tighter array distribution than it used to be. And on here you really can't see the difference. What you can see is that the rays look like they're now converging pretty much to a perfect point. You can zoom in here by just taking your cursor and holding down the left mouse button and zooming in there. And you can see that it's really, not perfect, but it's not too bad. And the display up here shows in microns or in millimeters. So, that's a couple of microns of variation there. Got 10 microns. Whole lot better than it was before. Oops. Okay, so that's it.